Hello. À,
Can, okay, right. So I just want to refresh your memory. In our previous lesson, we have learned how to integrate a polynomial. Integrate a polynomial means we try to integrate term by term, right? Term by term.
ừ,
So it's something like this. Okay. And
ừ,
okay. So we integrate this, x to the power 2 become x to the power 3, then divide by 3. This is x to the power 1. So you integrate becomes x to the power 2 divided by 2, and so on. Now, I've also shown you that there are two types of integral. The first one is indefinite integral without upper and lower limit. The second one is definite integral with upper and lower limit. I've forgotten that I didn't teach you this one yet. Never
ừ,
mind. We will come back to this. We'll come back to this. So how are we going to integrate, right? So we are going to integrate one term by one term. So let's say the function consists of three terms, 2x plus 3 minus 5 over x squared. So you cannot integrate them all at one time, but you integrate one by one. So integrate 2x become 2x to the power of 1. So become x to the power of 2 divided by 2. The 2 here, you just leave it there. No need to integrate. And I've also told you that if you integrate a number, let's say 3, 4, 5 like that, then it will become the number multiplied with x. Number multiplied with x is somewhere here. Somewhere here. No, not this one. I don't know where it is. Okay, so okay, where is it? Okay, so if you try to integrate this type of term with a denominator there, you have to change to x to the power of -2, right? From here to here, you have not integrated yet. So the integration sign is still there. The number, you don't have to integrate, you just leave it outside. Then x power -2 plus 1 becomes -1. Then you divide by the new index that is -1, right? Numbers you put outside, then x bar -1 is 1 over x. So the same thing apply to integration of terms with fraction, the indices where the indices are fraction. So let's say, for example, this one, the index is a fraction 4 over 3. 4 over 3 plus 1 becomes 7 over 3, then divide by 7 over 3. If there's a number in front here, then the number you just write down, don't integrate that number. So this is how we integrate a polynomial, I mean, term by term, one term by one term. Next, I also show you that, let's say if there are bracket like this, you cannot integrate them straight away. You have to expand until it becomes a polynomial. So once it becomes a polynomial, then you can integrate one term by one term. So you integrate one by one. So here also the same thing, you have a bracket. So you have to expand the bracket, then you integrate them one by one. Okay, this is for multiplication. Now for division, when you have two functions, one at the top, one at the bottom, how are you going to integrate them? So again, you cannot integrate them term by term straight away. You have to simplify them. Okay, this one divide by 3x, 2x squared divide by 3x, 5x, 5x divided by 3x. So you change them to term by term. Then after that, you simplify. Now simplify this, become x squared, 2 over 3x, cancel, become 5 over 3. Then you integrate one by one. The same thing here, you have two functions, one at the top, one at the bottom. Now this time, at the bottom there, the denominator has two terms. So you cannot actually split them up to x and 1, cannot. So what you can do is you factorize them. Factorize, then cancel away one of the term. Cancel away one of the term, then the term remain behind, you integrate. Okay. So these are the technique we have learned how to integrate them. There is integrate term by term, and if you cannot integrate term by term, you have to expand them into term by term, then you integrate. So if you cannot integrate straight away, you have to divide first. Divide, cancel away the common factor, then only you integrate them term by term. So these are the methods that we have learned how to integrate a function. But sometimes the function is very complicated. So it's something like this, right? You have a bracket, then raised to a certain power like this. You have a bracket, then inside the bracket, you have some more terms there. Then you have to raise to a certain power. So this time, you cannot expand. The reason is because of the n here. Let's say if the n here, 3x minus 5 raised to the power of 6. Now, so far, what we have learned is we integrate term by term. But this one, x to the power of 6. So you have to expand them using binomial theorem. You still remember the binomial theorem that we have learned the first time I taught you, the first lesson? The binomial theorem, you have to expand, then you come out with one term, then you integrate term by term. But that one is very complicated. Then you see, this one, bracket raised to power 6. Raised to power 6 means you have 7 terms. You have 7 terms, then you have to integrate 7 times. Very difficult. So we're going to use a method called substitution. This one. So the method that we are going to use is called substitution. Okay? We are going to use substitution to do all this. Whenever you see there's a bracket raised to a certain power and that power is more than 2, 3, 4, 5, 6, you don't integrate already. You must think of substitution. Okay? So I'm going to show you how to integrate. This is another method of integration. How to integrate using substitution. Okay. Now, can you recognize this function? 3x minus 5 to the power of 6. Once it is raised to the power of 6, you cannot integrate them, right? You cannot integrate them. You have to integrate term by term. If you cannot integrate term by term, you have to use a special method called substitution. Now, how to substitute? You see the function that is inside this bracket there. Inside the bracket, is 3x minus 5. So you let u equals to 3x minus 5. You create a new variable called u. Okay? Or the substitution method, you have to create a new variable called u. Or you want to call it other letters, never mind. But we usually call it u. Usually using substitution, we call it u. So we let u become the function that is inside the bracket. So inside the bracket is 3x minus 5. So u equals to 3x minus 5. That is the first step. Okay, first step. Then the second step is you differentiate u with respect to x. Differentiate u with respect to x. So du over dx, you still remember how to differentiate? Yes or no? Yes. So differentiate 3x become 3. Then we separate the du and dx. So the dx you bring over to the other side. So du equals to 3 dx. 3 dx, bring over to the other side. But if you look at this question here, what you have here is du. So you have to make du Sorry, what you have here is dx. I want to find out what is this dx. So I bring the 3 over. So dx is actually du divided by 3. So dx equal to du divided by 3. So far, can follow or not?
Okay.
Okay. So what you need to do is, what is inside the bracket? You call it u. Then you differentiate u with respect to x. After differentiating u with respect to x, you separate the dx and the du, right? Separate the dx and du. Okay, so until here, until this step here. Okay, right. So you leave this aside. Leave this aside. Then we come back to this question here. This question, this one, right? So 3x minus 5 to the power 6 dx. Now, we already call this 3x minus 5 u. So I replace this 3x minus 5 with u. So instead of 3x minus 5 to the power of 6, we have u to the power of 6. Okay enough? Okay. Then the problem comes with this dx. What is this dx? I cannot differentiate u with respect to x. Satu itik, satu ayam like that. You cannot. They cannot communicate with each other. The ayam and the itik cannot. So you have to change this dx into du. How to change the dx to du? We come back to what we have done earlier. Dx is actually du over 3. So instead of writing dx, I write du over 3. So can you see the blue color replaced with the blue color? This one is what? Pink or pink. This is what? Orange, orange or chocolate, I cannot see. Orange, then I change to this. The orange, I change to orange. Can or cannot? Can follow so far? Huh? Can. So we transform. What we are doing is we transform this, all the xxx, which is very difficult to integrate. We transform them to u. Once they become u, you see, I only need to integrate u to the power of 6. Easy lah, right? Easy. Now, before I integrate, I take out the 3, become 1 over 3. Because the 3 is at the bottom, become 1 over 3. Then actually, I'm trying to integrate u to the power of 6 du. So integrate u with respect to u. Can or cannot? Can. So u to the power of 6, you integrate, you increase the power by 1. U to the power of 7 divided by 7. 3 times 7, 21. So the answer is u to the power of 1 over 21 times u to the power of 7 plus c. C, you always have c there. C is an arbitrary constant. But the question gives us in terms of x. You don't leave the answer in terms of u, although this is correct. But you have to replace the u back with x. The u is actually 3x minus 5 to the power of 7 plus c. Okay, right. So far, change from x to u can follow or not? Change all the x to u. Can?
Can.
Okay. Then when you change everything to u, it is very easy to integrate. If you change everything to u and it is very difficult to integrate, then something is wrong with your substitution. You don't know how to substitute. You use the wrong substitution, right? So you try to look again at the question, how to substitute. Okay, so this one very simple. You integrate as usual. After integrating, you change back to x. So you go through this step here, and also this step here. If you cannot understand, you ask me. If can, then I go on. I carry on.
The bracket thing inside I change to u, and then
Left
the dx
left hand side or right hand side? Left,
Right hand
right,
side.
left. Okay, left.
Right,
1,
right, right.
3. 1,
Right
2.
hand side.
Oh, right hand side. Okay. 1, 2, 3. Which one? Which step?
Uh, one.
1. 1. U to the power of 6 du over 3. Okay, right.
The
Now
bracket
this is the
thing inside there.
sorry.
The bracket thing inside there, I change to U, and then the dx, I want to differentiate the things inside the bracket and then put du over the differentiate thing.
Okay, no. No differentiation. The thing is, this is the question, right? This is the question. I substitute. Substitute means you replace. You replace 3x minus 5 with u. You replace dx with du over 3. No differentiation, no integration yet. Just substitution. Substitution means you replace the original one with something new. So this is replacement. Replace this with this. Replace this with this. What is your question? Huh?
Dx become du over 3.
Correct. Correct. How to get this? Dx become du over 3 from here. Right? This dx. That's why after differentiating here, you have to separate the du and dx. After separating them, you make dx the subject of the formula. Any more question?
No.
So this one can, right? Then I want to show you one more example, then I'll let you try, right?
Mm.
Or you want to try straight away? This one? Okay. So now this one, 2 over x minus 3 squared. As I have told you, whatever that is inside the bracket, you give it a new name called u. Differentiate u with respect to x. Separate the du and dx. Okay. You try and do that. You copy down this question first, then I switch to the other page for you to refer. You copy this. This one. Now copy down.
Okay.
Okay, right. So now you refer to this. See you can do or not. You refer to the working here. Then you WhatsApp me the answer. Okay. Integrate 2 over -2 dx. Hey, you don't put the x inside. This is no, cannot, the 2 cannot multiply inside. The 2 is at the top. Okay, let me see how to do it. Copy, paste, rotate. Okay, then copy. Okay, where to put this? Okay, put this here. Edit this. Okay. First of all, this is what I've shown you, but this one cannot go inside. The 2 cannot multiply inside because there is a bracket here. And the bracket is not the ordinary bracket. This one is raised to the power -2. Your 2 here has no -2, so you cannot multiply inside. So 2 is just a number, you just leave it there. Don't multiply inside. So what you need to do is you let this one, wait, where's my pencil? The tools, cannot see the, got, okay. So let me show you the pencil. Okay, right. So it is like that, integrate, then 2 bracket x -1 -2 then dx. Okay, right. Now I told you this one cannot multiply in. The 2 cannot multiply in. Why cannot multiply in? Because the bracket is raised to the power of -2. And your 2 here not raised to the power of -2. So the next step is let u equals to x -1. X -1. So you differentiate du over dx equals to 1, equal to 1. So du equals to dx. That's all. So from here we put down, right? Put down here. So this is integrate 2. Then this x -1 is u. So it becomes u to the power of -2. Then here the x, I cannot put back the x here because I cannot integrate u with respect to x. So I have to change this dx. I look here, oh, dx is actually du. So I put the du there. Put the du there. The 2 is a number you don't integrate. So become u to the power -1 divided by -1. So yeah, this is correct, but it's not hard. The 2 is at the top. So this is 2 -2 times -1 is -2 over u -1. So u is at the bottom. So this one becomes -2 over what is u? U is x -1, then plus c. So you do the correction. You do the correction on this piece of paper, right? You just see where wrong. I think from here onwards, all wrong already. They are all wrong. So you copy down the correct answer. Then I give you another one to try. I give you another question to try. You copy down the answer first. Ready?
Wait.
Okay. Now, before I give you another question, so far, can you follow this one? Let it be you. Whatever inside the bracket there, you call you. Then you start to change everything to you, then integrate. Can follow?
Can.
Can. Okay. So now I give you another question. Okay. Where is it? This one. Okay, this one. So this one got a -3 there. You better be careful. You try this. Okay, try this. This one, you change to this. Then I switch to the other page for you to refer. You copy down this. Already?
Okay.
Okay, now you refer to this. Okay. Okay.
Mm.
Okay, let me see.
don't know how to change the answer go up.
How?
I don't
You,
know how to change the thing go up.
oh, okay. Sorry, huh? You go up means 5. 5, then the number like that, then it become go up. This one, because -3 become -2. -2 means at the bottom. Number at the top go to the top. Number at the bottom go to the bottom. You send me the what you have written, then only I can explain from there. Then only I can point out what is your difficulty. Then I can see. This is correct. This is correct. Then you must know how to change. You must know how to change. Okay, right. So this 5/3 you don't integrate. This whole thing is your u, right? So become u to the power -1. Then du equals to dx equals to du over -3. This is correct. So all this is correct. Now this number here, -3, can put outside here. 5/9. 5/-9. Then you integrate u to the power -2, u to the power -3 become u to the power -2 over -2, right? So this thing you take outside. You take outside, it becomes like that. It becomes, let me see. It becomes the 5, it's still 5. Then this -3 times -3 is -9. -9. But the problem is this one don't have the integration sign. This one no integration sign, so I just draw the integration sign here. Integrate, all right? Integrate this thing. U to the power of -3, -3 du. So this one is -5/9. -5/9. Then u to the power -3 become what? Can you tell me? Integrate u -3.
U -3 -2
Then
over -2.
-2. Then plus c. So this thing all multiply. Negative become positive. Right? Then the 5 is at the top. 9 times 2 is at the bottom. Then u to the power of -2 plus c. So now the time up already. So you just clear all this. I mean, you change this back to x, then you show me. Okay or not?
Okay.
This one you change back to x, and your integration is this is correct, right? This one is correct. So you have to integrate, change back.
Mm.
Okay, can you copy these steps, then you send me the one that you have changed.